One summer evening, almost a decade ago, our daughter returned from a play date with her friend. And very quickly, my wife and I noticed that she had swelling in the eyes, watery eyes, redness, as well as some rashes. After a few frantic phone calls, both to her friend's mom as well as the pediatrician, we quickly realized that she had spent the better part of the afternoon playing with a new cat that her friend had adopted and that she is allergic to cat. This instance started us on a journey, decade-long journey that led to a scientific breakthrough for managing cat allergens that I'll be talking about today. My name is Dr. Ebenezer Sathiraj. I'm an immunologist, and I'm currently Director of Molecular Nutrition at Nestle Purina Research in St. Louis, Missouri. I lead a team of brilliant scientists who focus on trying to understand the relationship between nutrition and health at the molecular level. I started my career in academia, finishing a postdoctoral fellowship at the University of Chicago in Chicago, Illinois, then moved on to Northwestern University to be on their faculty before moving into industry, the pharmaceutical industry, where I conducted research in the area of inflammation and disease. I came to Nestle Purina Research in 2003 with the goal of setting up a nutritional immunology program. And part of the work that I'm going to be talking about really came from the work that was initiated during that period. In my talk today, I will be starting by answering a fundamental question, which is what causes human allergies to cats? Then I'll move on and give you a quick overview of this novel nutritional approach that we'll be talking about. Then I'll finish up by walking you through several scientific studies that shows both the safety and the efficacy of the approach. So let's begin by looking at the problem. Cat allergy is a major problem. It's one of the most common animal origin allergies in humans. The numbers based on countries vary quite a bit, but worldwide, on average, 1 in 5 adults, which is about 20% of the adult population in the world, have some level of sensitivities to cats. And as you look at the data, the level seems to be increasing over time. Cat allergies has significant consequences both for humans and cats. For cats, it limits the interaction between the allergic person and the cat because people who have allergies tend to avoid interacting with the cat. Now, this can be extremely challenging for the cat as well, has consequences for the cat because although we think cats tend to kind of live by themselves, they do crave for interaction with their owners. The other way that cats can be impacted is that one of the most common recommendations that you'll get from your allergist if you're allergic and have a cat in the household is can you remove the cat from the home to be able to help you with the allergies. It's one of the most gut-wrenching decisions for anybody to take, but therefore it's one of the most commonly provided reason for relinquishment of the cat. And finally, of course, it's a significant barrier to cat ownership and adoption. Allergies to cat also have consequences for humans. Allergies typically cause fatigue, poor quality of sleep, reduced alertness, lower productivity and concentration. There are significant side effects of the medication that people take to be able to manage their symptoms. And above all, there is this emotional toll. You have a pet, you love the pet is part of your family, a member of your family, and you're not able to interact with them as closely as you'd like because of your allergies, and that can be a significant emotional challenge for most individuals. So in a nutshell, cat allergies have consequences both humans and cats and have something that needs to be addressed. Let's move on to what is the primary protein or the allergen that causes cat allergies. Cats produce several allergens, but the most potent, the most common allergen that almost 95% of the cat allergic individuals respond to is to the protein feldiwan. Feldiwan is produced by all cats, regardless of breed, age, sex, weight, hair length, color pattern, etc. There are no truly hypoallergenic cats, and this is an important point that I like to emphasize. If you look at the cat on the picture, which is a hairless Sphinx cat, even they produce some level of FeLV1. And this is an important point for all us to keep in mind because there is some mention about certain breed of cats to be very low allergenic. That is not true. What we know from the studies that we have conducted that is that even within a breed, cats produce different levels of FeLV1, and we'll see a little bit of that in the next few slides. FeLV1 is primarily produced by salivary and sebaceous glands. There is some production both in the anal glands as well, but the primary protein that gets transferred to the hair is believed to come from saliva as part of the grooming process that all cats indulge in. As saliva gets deposited on the hair, it forms dander, which then gets released into the environment. FeLV1 is easily airborne and remains airborne for a long number of time as small particles. FeLV1 also tends to be an extremely sticky protein, so it tends to stick on to clothing. In fact, a study that was conducted in Sweden noted that even kids who do not have a pet at home, a pet cat at home, get exposed to a significant amount of FeLV1 protein because kids who have cats at home as pets tend to bring them into the school environment, attached to their books, to their clothing, to their coats, etc. In fact, studies have shown that even homes or buildings that are brand new, newly constructed building where no pets have ever lived, you can detect significant amount of FeLV1 because it gets tracked from the people who come to work in these buildings, construction crew, etc., tracking FeLV1 through their hair in their jackets, in their coats, in their shoes, etc. So it is a very ubiquitous protein that's present all over the environment, and that is something to keep in mind also as we think about solutions to be able to address that. So as I described earlier, we did a study where we evaluated 60 cats over a period of a year, looking at their salivary FeLV1 levels. And we had several interesting findings that I would like to quickly walk you through. So what you're seeing here are two representative cats from the study. And what you can immediately see is that although these cats are not particularly known to be low allergen breed, these are just domestic short hairs, you see that within that group of cats, there seem to be cats that have very low levels of FeLV1 and other cats that tend to have a very high level of FeLV1. The other interesting finding is that if you look at some cats as you follow over the year, there are some cats that tend to have their FeLV1 levels vary quite significantly during that period, and others not as much. So for instance, if you look at this particular cat, she started with a low of 4.2, but a high of 322. So there's a huge range of FeLV1 levels that she had over the period of a year. Whereas if you look at this particular cat, the level was much more tighter, only between 0.1 and 1.2. Now, this is interesting. Is if you look at some of the experiences that I've heard talking to people, I shared these results with a veterinarian at a meeting in Europe, and this veterinarian colleague of mine, and her husband, who happens to be allergic to cats, foster cats for over 20 years. And she mentioned that in the 20 years or so that they've been fostering cats, there are a few cats that her husband did not have any reaction to at all. In fact, two of those cats they ended up adopting and keeping them as part of the household. And when she looked at this data, she said, this might perhaps explain why my husband doesn't react to these cats because perhaps they have very low levels to begin with. And this is an interesting insight and perhaps relevant to some of the experiences that you might have had as part of your practice or talking to friends. The most important last point that I want to make about FeLV1 is the fact that the biological function for FeLV1 is unknown. Therefore, the potential health and welfare effects of stopping its production are also unknown. And as you'll talk as part of the study that we have done, this is a hallmark of the approach that we have taken, in that the approach that we are proposing does not stop the production, does not alter the production of FeLV1, does not destroy the FeLT1. In fact, it retains the normal physiology of FeLT1 in the cats. Let's now move on and take a look at the current management strategies that people use to manage allergies. So what you're seeing here is the path that the allergen takes from the cat to the environment, and then people who are allergic to cats tend to get exposed to the allergen and then start developing allergic symptoms. If you overlay that with the management strategies people currently use, it again falls into three buckets: strategies that revolve around the cat, strategies that revolve around the environment, and strategies that revolve around the allergic individual. The two strategies that is commonly recommended today that revolve around the cat is relinquishing, which is removing the cat from the household, or avoiding interactions. Both of these are difficult to implement, as we will see in the subsequent slides. The second approach is trying to manage the environment, and this really involves a lot of cleaning to be able to keep the allergen levels low. In some cases, it involves changing to hardwood floor, removing carpet and replacing it with hardwood floor, washing or changing upholstery very frequently, all with the intention of trying to remove the amount of allergen that gets accumulated in a home that has a cat. The third sets of strategies revolve around the allergic individuals and really fall into two categories. One, strategies that prevent symptoms once the person is exposed to the allergen, and this involves primarily immunotherapy, where you prevent developing symptoms when you're exposed to the allergen. And then once you develop allergies and start having symptoms, you manage these symptoms by using medication. Let's quickly walk us through the limitations of the approaches that I described. Let's begin with approaches that revolve around the allergic individual. The two that we talked about are immunotherapy and treating symptoms of allergy. Immunotherapy, as you all know, can be costly and can involve long-term treatment, sometimes years. And interestingly, immunotherapy is believed to work effectively for certain allergens. But if you look at data for efficacy for cat allergies, the data is very limited. Most studies suggest that the efficacy for cat allergies tend to be very limited. If you look at people addressing the allergen by managing the symptoms, either they take prescription drugs or over-the-counter medication, all these involve drugs that are antihistamines or decongestants. All these tend to have significant side effects and, of course, the cost involved. The other key thing to keep in mind is that both these approaches only benefit the individual who is taking them. People who undergo therapy will have benefit. If you have symptoms, you need to take medication. So in a household where you have multiple allergy sufferers, each of them has to go through this process to be able to get the benefit. Let's move on to the environmental controls. And this typically involved, as we described earlier, cleaning, but also filters that can minimize the amount of allergen that gets recirculated in the household. These factors do tend to work in terms of reducing the allergen in the household, but they involve significant amount of effort. They're costly, and it is very hard to have long-term compliance because you need to be able to do this day in and day out as part of a regimen to be able to effectively manage allergen in the household. Then we go to approaches that revolve around the cat. And the two approaches that I talked about was one, removing the cat from the household, and the other one was avoiding interaction with the cat. Both these are extremely challenging for cat owners to involve with. If you talk to allergists, one of the most common recommendations they would give to their patients who has allergies to cat is to remove the cat from the household. And this is extremely gut-wrenching because the reason you adopt a pet is because you love pets. They're part of your family, and it is very hard to be able to give somebody away. In fact, talking to some of the allergists, one in particular who's a pediatric allergist, and her comment was, every time I have a mom or a dad bringing their child to me for evaluation, and I realize that following investigation that he or she has allergies to cat, and I suggest, can you give your cat away? The immediate reaction that I get is, how can I do that? Because that cat is my child's best friend, pet, it is going to be heart wrenching for us to be able to give the cat away because it'll have a significant negative impact on our child. And in most cases, I'm pretty certain that this particular individual will never come to me. They will go and visit another allergist to get a second opinion. In fact, if you look at statistics, over 84% of people who have allergies to cat and have a cat in the household will refuse to give the cat away, but look for other solutions because it is a difficult decision for people to make. And of these, 20% would be more comfortable changing the allergist to get a different opinion rather than going with the recommendation that he or she would make. So that again talks about the bond that we have with our pets, and that is something important to keep in mind as we look at the overall impact of this problem. The other approach that some people have recommended is to bathe the cat. Technically, bathing the cat removes the allergen from the hair and therefore is likely to reduce the amount of allergen that this cat is going to release into the environment. But bathing a cat is challenging. As you all know, cats are not dogs. Therefore, this is an approach that is not typically recommended. Let's now look at the approach that we will be talking about, and it is important to be able to really understand the journey of LD1 as we get prepared to understand this novel approach and describe this novel approach. So what we saw so far is that FeLD1 gets secreted in the saliva. It then gets distributed through the hair during the grooming process and eventually enters the environment as shed hair and dander. We saw it stays up in the environment and gets to released into the environment and gets sticking onto carpets, upholstery, clothing, and that's how it gets disseminated within the environment. What happens when somebody who's allergic encounters the FeLD1 is that it goes and binds to receptors that are present on the mast cell. These receptors are called as IgE molecules. So if a person is allergic to cat, they tend to have IgE molecules that are directed against FeLD1. These IgE molecules are present, bind to mast cells that are distributed throughout the body. When FeLD1 molecule binds to these receptors on mast cell, it triggers a degranulation event that leads to the release of factors that results in the development of allergic symptoms. A great example of a factor like that is histamine. That's why when you have allergies, you take antihistaminic drugs. The other important idea that I want to kind of give you a quick overview and an understanding of is this concept of allergen load. Both these are important to understand the novel approach that we're talking about. Now, what you're seeing here is this red line kind of graphically describes a threshold above which, if the total amount of allergen goes above that, you start having allergic symptoms. If the allergen load remains below that, you do not have allergic symptoms for this particular individual. So let's start by building in the allergens that are commonly present in the environment. And as you all know, most people tend to have allergies to more than one particular allergen. So let's look at allergen layer. This is apparently present throughout the year in the household, spring, summer, fall, winter, etc. If you build in, you have allergen B, same situation present throughout the year. Allergen C, which is also present throughout the year. And if you combine the total allergen load, including allergen C, it is still below the threshold of the allergen. So you are not likely to have symptom. This individual is not likely to have symptom at this stage. If you build in additional allergen that goes on top of C, which is D, you can see at some points in the time your threshold goes above and you start developing allergic symptoms. Now, if you assume that, let's take for the example as an example, if C is FeLD1, if you're able to reduce the amount of allergen in the environment by how much allergen the cats are depositing into the environment, you're likely to keep the allergen load below this threshold for most of the year and therefore likely to have a benefit. Now, again, I'm trying to explain this as a concept. This is very unique to each individual, the level of sensitivity, the different allergens that they're responding to. But the concept that I want to share with you here is that you want to be able to keep the allergen below a certain threshold to be able to have no or reduced symptoms. And the approach that we're taking is to be able to have a diet that I'll talk about that actually tries to do exactly that. So before we go on to the next part of my talk, where I'm going to give you a quick overview of this novel approach, let me recap the key things that we learned in the first part of my talk. FeLD1 is the key allergen that most people respond to. It's a protein that is produced in the saliva as well as sebaceous secretion, gets released into the environment through the grooming process, where FeLD1 is deposited onto the hair, dries, forms dander, and gets into the environment. An allergic individual has IgE molecules that are specific for FeLD1 that are bound to mast cells. And when FeLD1 comes in contact with this particular receptor, there is a degranulation event that leads to the release of factors that cause the allergy. If we block the interaction and prevent the degranulation event, you're likely to have a benefit of not having those factors released. The final concept that we walked through was this idea of allergen load, where you want to be, the goal is to be able to keep the allergen level below a certain threshold for somebody not to have symptoms. And this is something that is also very unique for that person, for the environment they live in. But as a concept, the idea is to be able to reduce the allergen load in the environment. With that, let's quickly go into a quick description of what this novel approach for managing FeLD1 is. So the goal of the approach for us was not to stop or alter the production of FeLD1 because, as we discussed earlier, its function is not clearly known for the cat, and therefore you do not want to interfere with this production or suppress its production, but to be able to look at an alternative way of trying to keep the levels of allergen in the household below a threshold where symptoms are less likely to happen. And we use an antibody technology, IgY egg antibody technology, to be able to achieve that, and I'll quickly walk you through that. This is a technology that's been proven to be safe and effective for decades. So a couple of words about what is IgY technology. IgY is the avian equivalent of mammalian immunoglobulin. And egg-based IgY ingredients have been used for decades in the livestock industry, and now getting a lot of interest from the human dietary supplements. So it's a safe ingredient that's been used quite extensively in the food space, and this is the technology that we'll be using to try to reduce the amount of allergen that gets into the environment from the cat. So let's look at this video that talks about that describes our idea of using antibodies, egg antibodies directed against FeLD1 from binding and neutralizing FeLD1. So if you look at the video here, what you see here are these are two IgY antibodies that is specific for FeLD1 that tends to bind FeLD1, which is the protein that you see in the center. Let's look at that. That's your FeLD1 protein. These are IgY antibodies. So they are blocked and they have neutralized it. And this is what happens when a neutralized FeLD1 tries to bind to the IgE molecules that's present on mast cell. And what you're seeing here are the two IgE molecules that are depicted. This will be present on a mast cell. You can imagine a cell out there. Under normal circumstances, when the FeLD1 protein comes in contact with these, it will bind these epitopes, these green surfaces that is marked, lead to what's called as a cross-linking event, and that is what triggers the release of factors that causes symptoms of allergy. Look what happens when a neutralized FeLD1, in other words, a FeLD1 that's been bound by anti-FeLD1 antibodies derived from egg, tries to approach these two receptors. As you can see, the normal process of binding here is disrupted. It is no longer capable of binding to those receptors and therefore incapable of eliciting a degranulation event, causing the release of factors that would cause symptoms of allergy. So that's the fundamental concept with which we started this work. If you put all that together in kind of a whole process flow, it starts by feeding cats a diet that's coated with egg ingredient containing anti-FeLD1 IgY antibodies. As the cats eat, this antibody gets released into the saliva, and it binds to the FeLD1 that is released into the saliva in the cat. and these antibodies neutralize the FeLD1. This neutralized FeLD1 is then transferred to the hair during the normal growing process. And then when neutralized FeLD1 comes in contact with, it's unable to activate the key steps that are required to do a degranulation event. It's no longer recognized as an allergen when it's released into the environment. So that's the fundamental idea with which we started this work. I'm going to move on to the last part of my talk, where I'll walk you through several key studies that were done to be able to establish both the safety and the efficacy of the approaches. The studies that I'll be talking about fall into two categories: in vitro and ex vivo studies. These were studies that were conducted in the laboratory, and in vivo studies that were conducted in cats. In the in vitro and ex vivo studies, the primary goal of that whole series of work was to really establish that our hypothesis, which was an antibody neutralizing FeLD1, prevents FeLD1 from binding and activating a mast cell. We wanted to really prove that hypothesis with laboratory experiments. After having done that, we moved on to do studies with cats, where first we wanted to establish the safety of this approach for the cat. Then we did two studies where we were able to clearly demonstrate that feeding cats a diet containing anti-FeLD1 IgY clearly reduces the amount of active FeLD1 that's present in their saliva and on their hair. So let's begin with the first data slide. This is one of the various experiments that were conducted. The first set of experiments that I'm not going to be showing today clearly showed that you can physically prevent FeLD1 protein from binding human IgE molecules if it's neutralized with an anti-FeLD1 IgY antibody. What you're seeing here is that preventing that interaction has clear biological consequences. So let me quickly walk you through what we have here. What you're looking at is an experiment that actually measures the ability of FeLD1 and initiating a degranulation event, and our ability to show that if you neutralize the FeLD1, you're able to significantly reduce this degranulation event, which is the key hypothesis with which we started this idea. What you're seeing on the y-axis is the degranulation event that is depicted in these blue bars, and it's set at 100%. What you're seeing here is mast cells are binding to FeLD1, which is not neutralized, and you're clearly able to establish that there is significant amount of degranulation. You set that at 100%. Then you see what happens when you now challenge the mast cell with the FeLD1 protein that is neutralized. What you can clearly see is that you're able to prevent or reduce the degranulation process by as much as 60% when you're now challenging the mast cell with a FeLD1 molecule that is neutralized with anti-FeLD1 IgY. What you're seeing here are control experiments where if you use IgY that is not specific for FeLD1, you do not have any impact on reduction of degranulation event. So what this data, these sets of experiments clearly showed that the hypothesis which we started has significant merit in that if you prevent FeLD1 from binding to human IgE by neutralizing it using an anti-IgY antibody, you're clearly able to prevent the degranulation event that is required for the symptoms of allergies to happen. Having established that, we then moved on to do studies with cats. And the first study that we wanted to establish was the approach is safe for cats. And this is paramount in all the studies that we do as Purina, where we put the safety of the cat at the heart of all the work we do. As you all know, we are pet owners, we love cats and dogs, and we want to be sure that anything that we do, above all, has no negative impact for that. So this was a very crucial study for us to complete before we started the other studies where we could show the efficacy of the approach. Briefly, this was a 6-month study with 40 cats. Along with the control group, there were 3 other groups of cats that were fed levels that were many times higher than the levels of egg antibodies that were used in the efficacy studies. And during the 6-month period, we had a whole series of veterinary evaluations that were done. This included clinical evaluation. We evaluated body weight, food consumption, ophthalmic evaluation, blood chemistry, um, blood count, CBC, coagulation, urine analysis. There was also some behavior analysis done to see if there's any impact on the behavior of the cat. When we looked at the data after the 6 month of feeding, what we clearly demonstrated and noticed that there was no clinical difference between the control levels, where no anti-FeLD1 antibody were present, or any of the levels tested, clearly showing that this approach is perfectly safe for cats. This was work that was published late last year in the journal Frontiers in Veterinary Science. So, having established the safety of the approach for the cat, we went on to do our first study where we asked the question, does the approach reduce the amount of active FeLD1 in the saliva of the cat? For this study, we selected cats that had moderate or higher levels of FeLD1 expression so that we can measure FeLD1 reduction in these cats. There are some cats, as we saw earlier, that have very low levels to begin with. And if you include them in a study, if those levels are slightly above or below the level of detection of the ELISA, you really cannot show a decrease. So therefore, those cats are eliminated from the study. Saliva samples are collected 5 hours after the morning feeding, and the amount of active FeLD1 was measured using an ELISA kit, and this was evaluated as weekly averages. Now, let me tell you a little bit about what I mean by active FeLD1. The ELISA kit uses the same approach where the FeLD1 antibody has to bind to the capture antibody in the kit to be able to detect. A neutralized FeLD1, which is unable to bind to human IG, is also not able to bind to the captured antibody in the ELISA assay, and therefore the ELISA assay can only detect free FeLD1. In other words, neutralized FeLD1 cannot be detected, and therefore what I'm referring to active FeLD1 is FeLD1 that is still remaining in the saliva of the cat that is not bound by anti-FeLD1 IgY and therefore not utilized. When we looked at the data from the study, each cat served as its own control. And here are results from the study. What you're seeing here is weeks on the x-axis, and on the y-axis, you're looking at mean change from baseline from the statistical model that was used to evaluate the data. And what you can see is that while you do see a decline in the control group, there was a statistically significantly greater decline seen in the test group starting from week 3. In fact, you got a 24% reduction of active FeLD1 in the saliva of these cats starting from week 3 onwards. This was work that was published also last year in the Journal of Feline Medicine and Surgery. Having established the fact that the approach that we started with can clearly reduce the amount of active FeLD1 in the saliva of the cat, we went on to ask the question, what happens to the amount of active FeLD1 in the hair of the cats? So here's the summary of the findings from the study. So the first proof of concept study clearly showed that feeding a dry cat food coated with anti-FeLD1 IgY significantly reduced active FeLD1 in the saliva of the cat, starting with the third week of feeding. Having done this, we went on to ask the question, what happens to the amount to the hair FeLD1 levels? And for this, we designed the study to be able to ask the exact same question, which is, can a diet containing anti-FeLD1 antibody reduce the amount of active FeLD1 in the hair of this cat? This was a much larger study where we had 105 cats that were fed a control diet for 2 weeks, followed by a test diet for 10 weeks. Hair was collected by brushing the front, shoulder, and sides of this cat. Active FeLD1 was measured using the same ELISA assay that I described earlier and was evaluated as weekly averages, and each cat served as its own control. Here are the results from the study. What you're seeing on the y-axis is the weeks baseline and week 1 to week 10. On the y-axis, you're looking at the absolute FeLD1 levels in these cats here. And what you can clearly see is that, again, there is a decline starting from week 1 and week 2, but starting week 3, you start seeing a dramatic decrease in the amount of active FeLD1 that can be detected in the hair of this cat, and that lasts almost until the end of the study. This work was also published earlier last year in the journal Immunity, Inflammation, and Disease. If you look at the data overall, 97% of the cats showed reduction of FeLD1 levels as compared to the baseline. 86% of the cats showed a reduction of 30% or greater, and 50% of the cats showed a reduction of 50% or greater. And let me put that in context for you. What this shows us that the approach of feeding a diet containing anti-FeLD1 antibodies is clearly able to reduce the amount of active FeLD1 in the hair by as much as 50% based on the data that we have from the study. And that is kind of denoted here. If you look at the average reduction over the period from week 3 to week 10, there was an average reduction of about 40%, clearly showing that you're able to reduce the amount of active LD1 by almost 50% once these cats get onto the diet containing anti-FeLD1 antibodies. Let's go back to what we started here, because both these studies clearly shows that the approach of trying to use an anti-FeLD1 antibody as part of the diet is able to reduce the amount of active FeLD1 both in the saliva and in the hair. And as you saw in the last slide, there's a dramatic reduction of the amount of active FeLD1 that is detected in the hair. And if you connect that with the earlier idea of trying to reduce the amount of allergen in the environment below a threshold, this is clearly has the potential to be able to deliver that. So if you go back to the slide that we started, where we were looking at the current management of cat allergies, approaches revolving around the cat, approaches revolving around the environment, and then approaches around the allergic individual. What we're proposing is another approach that can be added to this overall strategy to be able to reduce the allergen level that eventually gets into the environment. What's unique about the approach, as we saw in the studies that I described, is that not only is it safe and effective, but it's also very simple to use. Because if you look at the earliest approaches, relinquishment avoidance challenging for an individual to adopt. Cleaning extremely tedious, hard to be able to keep maintaining, and of course approaches that involve the allergic individual, you have to have significant investment in time and effort to be able to get those benefits. The approach that we are proposing is simple in the sense that you have to just feed the diet. You don't have to do anything else. And the active ingredient in the diet is able to deliver the benefit of reducing the amount of active FeLD1. So not only is it safe and effective, but it's also extremely simple because you don't need to change any other routine that you need to do as part of the approach to manage the allergens in the environment. So the scientific breakthrough that I'm so excited to share with you and walk you through these slides is really a part of a comprehensive allergy management plan. And we believe this approach can reduce cat allergens while importantly keeping the cat in its loving home, which I know is extremely important for people like me as well as others who love their pets. So let's quickly summarize the key points that we discussed during this presentation. So the innovation delivers specific anti-FeLD1 antibodies, also called as IgY, in an egg product ingredient that is coated onto the cat's kibble. The anti-FeLD1 IgY is safe, and it effectively neutralizes active FeLD1 in the mouth of the cat as the cat chews the food. As cat grooms, the neutralized FeLD1 is transferred to the cat's hair. Neutralized FeLD1 is no longer recognizable as an allergen when released into the environment. And most fundamental to this approach is that the normal FeLD1 production is maintained and cats' overall physiology is not impacted. Thank you very much for your attention.